Hi there, Spark fans. Rob Reynolds here. Remember how difficult it was to get the power you needed in the old days? You'd call down to your chief engineer, tell him you needed more power, and he'd tell you he's given it all he's got, and you'd tell him to divert power from the impulse drive, and he'd tell you any more power to the main core and the whole thing would blow? Well, maybe that was the future. Or was it the past future? Well, whenever it was, things are better now. Why? Well, for one, we don't have to go flying around the galaxy looking for dilithium crystals. All we have to do is grab a USB-C adapter. A USB-C really changed the game. Aside from eliminating the possibility of putting your USB connector in upside down every freaking time, it also allows you to use anywhere from 5 to 20 volts with up to 100 watts of power. And now you don't even have to call down to engineering to control that power. You can simply use the SparkFun Power Delivery Board. This board uses the ST Electronics ST-USB 4500, an auto-run Type-C and USB power delivery controller that addresses sync devices. It has an input and output voltage range of between 5 and 20 volts, with an output current of up to 5 amps. It allows for up to 3 configurable power delivery profiles. The chip itself is certified USB Type-C revision 1.2 and USB PD revision 2.0. It has integrated V-bus switchgate drivers, integrated V-bus voltage monitoring, and internal and/or external V-bus discharge paths. Additionally, the CC pins have short to V-bus protections and have a voltage capability of up to 28 volts. And there's a quick connector to make programming the board over I2C a snap. So what does all this mean? It means great things. USB-C power adapters offer multiple voltage and current profiles. The ST-USB 4500 can store up to 3 power data objects, or PDOs. The power delivery board implements a proprietary algorithm to allow the power delivery contract with a source. We can see that the PDO number parameter is set to 3, which means that when we plug in the power adapter, the board will first try to find a power option matching PDO 3, which has a voltage of 20 volts, 1 amp of current, with a voltage tolerance of plus 10% and minus 20%, which gives us anywhere between 16 or 22 volts. If our power adapter is able to source between 16 and 22 volts with 1 amp of current, then the contract will be accepted. If not, then the board will go down and check PDO 2, which should be around 15 volts and about 1.5 amps. And if it can't do that, then it'll go down to 5 volts. Now, since this one can source 20 volts, our first PDO will be accepted. If you were to test the output with a multimeter, you would see 20 volts coming out. One thing to note, if you do contact this with a multimeter while it's powered up, chances are the board is going to shut down as a safety precaution due to the sudden change in capacitance. It's best to contact the multimeter to the output first and then power it up. And one of the nice things is, once you've programmed it, you no longer need a microcontroller because the board can be self-contained. So stop relying on other people to control your power and power it yourself. Trek on over to SparkFun.com and pick up your own SparkFun Power Delivery Board. And as always, happy hacking. If our power adapter, oh, I shouldn't start like that. Like I was surprised that I was shooting a video. Just have me stand here and then just do a Star Trek, like beam me up and just go to the blank wall. Power supplies offer a multitude, not a multitude, but multiple at least. Aside from eliminating the, it's a quest now. I want to say a plethora. Oh wait, that's an old video. We already used plethora.